quiz next week?
Yeah, quiz next week. So this week just homework 2. So cover P.5 and 1.1 and 2.1.
Okay, since there's a lot of questions for this week's homework, how do you want us to, like, you still want it on one PDF file, like page?
You can have one PDF but multiple pages.
Really?
Yeah.
Okay, do we just shrink one of them, or
Huh?
do we just shrink one of the pages?
No, don't shrink it. I want one page fit in one page.
Okay.
If you shrink it, it's so small, I cannot read it. So it's like you can have Word documents, Google documents, and you can like send yourself email the pictures, and then you use laptop to download it, and then copy and paste to the Word document, and make the picture larger to fit in one page.
Oh, okay.
Then you save as a PDF. So you have multiple pages, but one PDF.
All right, thank you.
Okay, good.
All right. So last time
We talked about 1.3. So we are a little bit behind schedule. Today we talk about 1.4. So last time I gave you the 1.4 handout. Do you still have it?
good. Okay, so let's start. Okay. All right.
Yes. Oh, okay. You're welcome.
Okay, quadratic equations. So a quadratic equations is an equation that can be written in the form of ax squared plus bx plus c. Here, a, b, c are constants, and the variable is x. Right, everybody? Quadratic degree 2. And we have solved quadratic equation by factoring and also by using the quadratic formula.
Let's review. So have you seen quadratic equations before? You learn factoring, right? And the quadratic formula, right? You learned before. Okay.
So this is just like a review then. So let's solve it by factoring. Okay, so first of all, when we solve a quadratic equation, make sure all the non-zero numbers, all the constants, move to one hand side. Okay, that is the first step. Let me write down the step here. Okay, move all terms to the left hand side. So LHS stands for left hand side. And then, let me put this in here. Then it will be better. So the right hand side is then 0. Okay. So the right hand side is 0. Let me see. Okay. I get my screen. Okay. Right. And then, so we move the 3 to the left. Here we subtract 3 on both sides. We get 2x squared plus 9x. What's 7 minus 3? 4 equals 0. So we move all the terms to the left hand side. And then we can factor. And next step, we set each factor equal to 0, and we solve for x. Okay, those are the steps. And now, how do we factor?
So you might learn, so this is a 1.4. You might learn several different ways of factoring.
Okay, so please feel free to use your way.
Because as long as you get the right answer, that's perfect. Okay, so the way I learned is I put 2 pair of parentheses. And then I look at the leading term. The leading term is the highest power term. Oh, yeah. And factors of 2x squared. Well, it must be x and 2x. Right?
everybody? So we put x and 2x here. Okay, those are factors of 2x squared. And then we look at factors of 4. Well, factors of 4, it could be 1, 4, or it could be 2, 2. Right, everybody? And because it's plus, so it could be plus plus or minus minus. So those are all the possibilities. Right, everybody? And then we try each pair. So let's try 1 and 4 first. So we put 1 here and 4 here. And let's try plus plus first. If that doesn't work, we tried minus minus. Okay, now we multiply the outer terms. X times 4, we get 4x. And then 1 times 2x, we get 2x. Right? Multiply the outer terms and multiply the inner terms. And then you see 2x plus 4x is 9x. It's not 9x. That's why this factory is wrong. Okay. Then how about we switch the order? Yeah, 1, 4 doesn't work. Try 4, 1. So this doesn't work. We erase this and try 4, 1. Multiply the outer terms, we get x. Multiply the inner terms. Do you see we get 8x? Yes, everybody? And 8x plus x is 9x. Good. So this is the factoring. So we try all different combinations. We try 1, 4. Then we try 4, 1. We try plus plus. If plus plus doesn't work, try minus minus. Okay? If those doesn't work, try the 2, 2. Okay? So this is the factory. That equals 0. Okay? By the way, I just want curious. How many of you learned this method to factor? Raise your hand. Just 2, 3. Okay. Other people, what's your way to factor? Is this one? Oh, okay. How about other different factoring ways? That one? Oh, okay. I know some of you do the factoring by grouping. So like we write 9x by something else and then do the factor there. Yeah? Yes, okay. So feel free to use different ways. Okay. And then, okay, now we set each factor equals 0. So the first factor, x plus 4, set it equal to 0. Or the second factor, 2x plus 1 equal to 0. Here we're using the rule that if a times b is 0. This is the same as saying a is 0 or b is 0. Okay? If a product of two factors equals to 0, that means either a is 0 or b is 0. And this rule is only true for 0. Okay, if you have like a times b equals 1, and that implies a is 1 or b is 1. No! For example, 2 times 1 half is 1. So a is not 1 and b is not 1. So this rule is only true for 0. Okay? That's why the first step, we move all the terms to the left-hand side. So the right-hand side is 0. This is so important. Okay? Because if your right-hand side is not 0 and you factor the left, it tells you nothing. Okay? If this is not a 0, you get a factoring, that tells you nothing. You don't know about A, you don't know about B, nothing. Therefore, the step 1, very, very important. Move all the terms to one hand side. Okay, let's see. Okay. All right. Okay, So we continue. Solve each of the following. Oh, not yet. We haven't finished, right? We want to solve for x. Therefore, subtract 4 and subtract 4, we get x equals minus 4. Right, everybody? Or, okay, what's x? Yeah, we subtract 1, we get 2x equals negative 1, and then x is negative 1 half. So this problem, we have two solutions. Okay, so usually linear equation, one solution. The quadratic equation, usually two solutions. Okay, but the possibility, it could be two solutions, it could be one solution, it could be no solution. So we will talk about that later. Okay. All right. How about the following? Well, following, if you have only the x squared, then you can isolate the x squared and take square root on both sides. Okay. So here, isolate the x squared, both sides divided by 5. Right, everybody? So we have x squared. What is 30 divided by 5? 6. And then, so we take the square root on both sides. We get plus or minus square root of 6. Right, everybody? Yes. So you have plus or minus. So this one, can we use that way? Can we use that way to solve? Instead of taking the square root on both sides, can I use that way to solve? Yes, we can. Then how do we do it? We move all the terms to the left-hand side. So we are subtracting 6 on both sides, right? And then you want to factor. Okay? So how do we factor? Well, review all those formula. What is a squared minus b squared? A plus b, yeah. A minus b. So I hope all of you, thank you, can memorize these formulas. They're very, very important. Okay. And if you have a squared plus b squared, what do you say? Can we factor it? Yeah, we can factor. And when you have a plus b squared, what's that? Is it a squared plus b squared? Yes. See, we just said a squared plus b squared cannot factor, so it cannot factor as a plus b times a plus b, right? So what's the middle term? 2ab. Okay, everybody? 2ab. And if we have a minus there, then we have a minus down there. Okay? So all these homework, make sure you memorize it. It's very, very important. Okay, so now, do you see this is like a difference of square? X squared. But 6. Let's express 6 as something square. Well, then we can think of 6 as like square root of 6 square. Yeah, it's square root of 6 square. So then we get, x plus square root of 6 and x minus square root of 6 equals 0. Therefore, x plus square root of 6 is 0, or x minus square root of 6 is 0. So x is negative square root of 6, or x equals positive square root of 6. So, you see, we have the same answers. But this way only works if you have a complete square. In general, if you have something like that, you cannot use this way. Is that clear, everybody? Yeah. Like here, this is a complete square. It's a whole base square. Okay? When you have a complete square, you can use this way. If
if you don't have a complete square, then do this, the factoring.
All right. So therefore here we isolate the complete square. Okay, so this is the complete square. We isolate it. Okay, isolate. That means we add 5 on both sides. Then 2 plus 5 is 7. Right, everybody? After we isolate the complete square, so then we can take the square root on both sides. Right? So when you take square roots, you have plus or minus. Right, everybody? You take square root, plus or minus. Therefore, what's x? See, we add 3 on both sides. We have x is 3 plus or minus square root of 7. Okay, everybody? See, we have 2 roots. One positive, one negative. So 2 roots. Okay, so that is factoring. And if we have a complete square, we can isolate it and take square root on both sides. Okay. Next is the quadratic formula. So ax squared plus bx plus c equals to 0. The quadratic formula. How many of you can memorize the quadratic formula? Okay, if you don't, write it down on a piece of paper together with this formula. Okay, write it down, and then maybe take some, make some copies and tape it on the door, on the wall of the door. Maybe you want to put one copy on your restroom door so you can see it every day. Yeah. Okay, so x is negative b plus or minus square root of b squared minus 4ac, then all over 2a. Okay, so this is a quadratic formula. Because we don't have enough time, so we don't derive or prove the quadratic formula in class. Is that okay, everybody? Just use it. Okay, and the expression inside the radical. So this expression inside the radical is called a discriminant. And usually we use a triangle to denote it. So triangle is the discriminant. Okay? It really determines how many solutions we have. Okay. So here, if the discriminant is positive, okay, if the things inside the square root is positive, well then square root of a positive number, this is a irrational number, but it's still a real number, right, everybody? So, like our previous problem, you have one root of the plus and you have one root of the minus. Therefore, we have two solutions. They are both real numbers. Okay, everybody? So if discriminant is positive, we have two real numbers, real solutions. Okay. So discriminant is positive, then we have two real solutions. Okay. And what is the picture look like? You know, line, linear function is a straight line. Anyone knows what's quadratic function? Parabola, exactly. So this parabola, let's say, looks like this. Okay, so this is a parabola ax squared plus bx plus c. And let's say we have two real solutions. They are R1 and R2. Okay, they are the solution. Then corresponds to the picture. The solution is actually the x-intercept. So the parabola crosses the x-axis in 2 points, and they are the x-intercept. And then you can also factor, so ax squared plus bx plus c can be factored as a times x minus the first root or solution and x minus the second solution. So this problem can be factored like this. Is that okay, everybody? This is what happens when the discriminant is positive. We get two real solutions. Okay. How about let's check this? Okay. Go back to our previous examples. Remember this one? Okay. So we know the roots are -4 and -1/2. Right? These are the two roots. So by that we have, so this is a, do you see a is 2? Yes. And then x minus the first root. You see the first root is -4. And then x minus the second root. Second root is -1/2. Right, everybody? So, oh, you see? This is 2. Minus negative become positive 4. And minus negative become positive 1/2. So what I'm doing, I can multiply the 2 inside this factor. Right, everybody? I can multiply the 2 with this factor and it's kind of distribute. So I get, so x plus 4 stays here. And then I distribute the 2 inside here. And I get 2x plus 2 times 1/2 is 1. So I get x plus 1. So therefore, this is exactly equal to the factoring. Yeah? So, yeah. So this is what this means. This can be factored as a, the leading coefficients, times x minus the first solution, times x minus the second solution. All right. How about if the discriminant is negative? Well, that means the thing inside the square root is negative. What is this? It's not a real number. It's imaginary complex numbers, right? Do you all know square root of -1 is I? Yeah, complex numbers. So therefore, no real solutions. We get two complex solutions. So no real solution. So we get two complex solutions. And they can be written as alpha plus beta I. Let's say this is the root. Okay. And if you look at our formula, because the things inside the square root is negative, so you have an I right here. And then the alpha corresponds to the real part, which is -b over 2a. Right, everybody? And then the beta is the imaginary part. How about in terms of the picture? What's the picture look like? Okay, we don't have a real solution. That means the parabola lies completely above the x-axis. Okay, so that's why we have no real solutions. Okay, so above the x-axis. So no real solutions. Okay, if discriminant is 0. Well, if the thing inside the square root is 0, do you see? This is 0. We only get one solution. Okay, everybody? So we only get one solution, which is -b over 2a. So one real solution. And let's say this is the solution is R. The solution is -2a b over 2a. And now you can express the quadratic equation as a times x minus the root square. It is a complete square. Okay, everybody? This is a complete square. That's why sometimes people say R is a double root. Okay, double root because of the 2. Okay, by the way, R is a solution, then it's also called the root of the function, or 0 of the function. Okay, and this is double root because we have this factor to the power of 2. So that's why. This 2 is also called the multiplicity. Have you heard of multiplicity before? It's the number property of that factor in the factorization. Okay, so in the picture, we have one solution. That means our problem touch the x-axis. So we only have one x-intercept. So far, so good, everybody? Only one x-intercept. Okay. So those are or 3 cases. So we can have 2 real solutions, 1 real solutions, or no real solutions. Okay. Solve the following equation. So example 3, I will leave you to do at home. Okay. Let's do example 4. Okay. Everybody look at me. Tell me what the quadratic formula. We have, how about, let's read it together. And then you close your eyes and tell me, okay? So let's read it together. Negative b plus or minus square root b squared minus 4ac over 2a. Okay, I don't see your mouth open. Okay, again. Negative b plus or minus square root of b squared minus 4ac over 2a. Now close your eyes. Say it.
Negative b plus or minus square root b squared minus 4ac.
Yes, very good. Okay, you can do it. All right. Now, this is what? A. Your B, be careful. Your B is negative 12. Okay? Your C is negative 17. Right, everybody? So, what's that? 12, negative B. B is negative 12, so negative B is 12. Right, everybody? And then? Plus or minus square root of? Okay, B is the number, no x. Okay, so 12 squared. Yes. And then? Minus 4. A is 3, yes. Over 2. Yeah, very good. Right, everybody? Negative b plus or minus b squared. B is negative 12. By the way, okay, let me do it slowly. It's negative 12, but when you square it, what happens to the negative sign? It go away, right? Negative 1 squared is positive 1. So therefore, this is 12 plus or minus. Do you know what is 12 squared? Yes, 144. And then minus become positive. Okay, 4 times 3 is 12 times 17, yes? all over 2 times 3 is 6. Bless you. Right, everybody? Okay, can we simplify it? Okay, can we simplify it? Yes, we might, but not much. Okay. What is 144 plus 12 times 17? Do you see the common factor is 12? Because 144 is 12 times 12. So we factor out the 12. We get 12 plus 17. Yeah, everybody? So I'm trying to simplify it. But because if you use your calculator, it just gives you a decimal. It won't be exact. So I'm trying to simplify it so we still get exact answers. Then this is 12 times what? Is it 29? Yeah, everybody? So this is 12 plus or minus square root of 12 times 29 over 6. But 12, what is 12? That is 3 times 4, right? How about let's put 3 times 4? Because the 4, we can pull out the square roots. What is square root of 4? 2. Yes? I can pull the 4 outside of the square root. The square root of 4 is 2. And then we're left with 3 and 29. 3 times 29 is 3 times 2, 6. 3 times 9 is 27. So 87. Right, everybody? 87. By the way, can I cancel the 12 and the 6 and I put a 2 here? Can I do that? Can I cancel the 6 and 12 and I put a 2 here?
Oh no.
No, because it's plus or minus. So we can only cancel if it's a product or it's a right? So, but you see 6, 2, and 12, they have a common factor of 2, right? Common factor is 2. So we can factor out a 2. What's the numerator after we factor out the 2? Yes. Now, can we cancel the 2 and 6? Yes. And if you have the product, then you can cancel. Multiplication and division you can cancel. But if you have addition or subtraction, you cannot cancel just one term. Okay, everybody? This is a common mistake. So 2 and 6. We cancel. What's left? Downstairs, 3, right? So we have 6 plus or minus square root of 87 over 3. So this is the simple one, right? Or if the problem says express your answer with 3 decimal places, then you type this in your calculator and get 3 decimal places. Okay, everybody? Okay, very good. Let's see. Example 5. We want to use the discriminant to determine the number of real solutions. Do so without actually solving the equation. So we don't want to solve the equation. We just want to know the number of solutions. Okay, discriminant. B squared minus 4AC. How about you guys take turns to answer my questions? Hi, what's your name? Quinn. What is B? What is B? So A is the coefficient of x squared. B is the coefficient of x. C is the constant term. So what is B in this case? 8. Right, anybody? 8. So B squared. A squared, and then what? Minus what? Your A is 1 coefficient of it. So A, B, C, they're all numbers, constants. So therefore, in your solution or in your determinants, you won't see x. So don't include x. So A is 1, B is 8, and C is 6. Okay, so A is 1, C is 6. What is 8 squared? Do you know what's 8 squared? 64, yes. What is 4 times 6? 24. So we get 40. Good. Is this positive, negative, or 0? Positive. So do we have one solution, two solution, or no solution? Positive? Positive, then we have two roots. Because one root is the negative b plus or minus. One root is the plus square root of 40 over 2a. The other root is the negative square root of 40 over 2a. So we have two solutions. Okay? Right? If the discriminant, think about this. Discriminant is the thing inside. If this is positive, then we have two solutions. One is plus, one is minus. Yes. Okay. So we get two solutions. Okay, next. What is B? Yes, negative 6. But when we put square, don't forget the parentheses, right? Minus 4. What's A? C? Negative 6 squared is? Yes, 36. 4 times 9? Yeah. Ooh, what's that? What do you say? How many solutions? One. One real solution. Yes. Right, everybody? Okay. Next. Hi, sir. Yeah. Okay. What is B? You mean negative 6, but when we square it become positive? Yeah. Minus 4a is C. What is negative 6 squared? What is 4 times 5 times 2? Yeah. What's that? Yes. Do we have real solution? Right. No real solution. Okay. Yes, so this problem, we just want to find the number of solutions. We don't need to actually find the solution. We just need to know the number. Okay, everybody? Good. Okay. Example 6. Use discriminant to find the values of k such that the following equation has exactly one real solution. So now we have a parameter k, right? So but we just imagine k is like a number. We want to find what's that number, so we have exactly one solution. So yes, what is a here? A is 1, right? What is B? K. C is 5. So discriminant B squared minus 4AC. B is K. So K squared minus 4. A is 1. C is 5. Oh, what's 4 times 5? 20. So exactly one solution. The discriminant is what conditions? Positive, negative, or zero? Zero. Yes. Right, everybody? We set it equal to 0. And we want to find k. What do you do? Yes. So we put the 20 to the other side first, right? Yes. So we get k squared equals 20. Is everybody okay with that? We both sides add 20. When we take square roots, what happens? Do you just get square root of 20? Yeah, plus or minus. Exactly. So here we have two values of k, such that the following equation has exactly one real solution. Okay, everybody? All right. So we keep going. Let's look at some application problems. So a rectangular sunroom is 3 feet longer than it is wide and has an area of 154 square feet. Find the dimension of the room. Rectangle. So rectangle, remember our two-dimensional figures? Rectangles, we have length and width, right, everybody? Okay, look at the first sentence. The rectangle, some room 3 feet longer than it is wide. So 3 feet longer. So length is what? So 3 feet longer than it is wide. So is the width plus 3. Yes, everybody? The width plus 3. Okay, everybody? That's the first sentence. And oh, the second part. Area. What is area of the rectangle? Yeah, length times width. And that equals 154. Alright. Do you see this problem? We have two unknown and two equations. So it should be able to help us to find the solution. We want to reduce the number of variables, right? Do you see L is W plus 3? Right? Maybe we should plug in here. Then we can eliminate the L. Right, everybody? So substitute. The L is W. Okay, so L is W plus 3 times W is 154. Now, do you see this is a quadratic equation? So what do we do? Peter, what do we do? How do we solve it? Do you see the right hand side is non-zero? Yeah. So we need to move all the terms to one hand side, right? So we subtract 154, right? So subtract 154 on both sides. We get W plus 3 times W minus 154 equals 0. By the way, this is not complete square, so I cannot take square root on both sides. Everybody clear? You only take square root if you have a complete square. What's complete square? Parentheses to the power of 2. That's complete square. Okay, so now, see, we gotta distribute. So we have what? W squared. Good, minus 154. Right, everybody? Okay, we're ready. So Are you familiar with factoring or more familiar with the quadratic formula? So really up to you. Maybe from now on, you got quadratic equations, you choose your method, either factoring or quadratic. Okay? So which way do you prefer? Do you prefer factoring or quadratic? Or which one? Doesn't matter. You do both? Oh, okay, good, good. Maybe let's try factoring, because this is W squared, so it's just W and W. And then, okay, the problem is 154. What's 154? What are the factors of 154? Let's try to figure that out. First of all, the last digit is an even number, right? So it's divisible by 2. Yeah, everybody? And then divisible by 2, we divide by 2, we got what? 7 times 2 is 14, and we said 14, so 77. Have you seen this before? We'll try to find the factors. So we get 77. What are the factors of 77? Yeah, 11 and 7. Okay, so what are the possible factors? Wow, that's a lot. 1 and 154. 2 and 77, right? 7 and 22. 11 and 14, right? And because it's minus, so it should be plus or minus plus. These are all the possibilities. But imagine the middle guy, see, is 3. 3 is so small. So this means one of the root is positive, one of the root is negative. Look at this. 154 minus 1 is 153. This here, the difference is so big. Yeah, everybody? We won't get 3. 77 and 2. 77 minus 2 is 75. It's still so big. 22 minus 7? 15. Still big. We need 3. 14 and 11. Yeah, 14 minus 11 is 3. So 14. And this is positive 3. So that's why we need positive 14 and negative 11. Okay, everybody? If this is negative, then you will need negative 14 and positive 11. Right. So positive 14, negative 11. Yes. Therefore, W plus 14 is 0, or W minus 11 is 0. So W equals negative 14, or W equals 11. We have 2 solutions. But when we work with real life problems, can your answer be negative? Do you have a negative dimension? No. So, therefore, the width must be 11. Then, what's the length? Huh? 14, right? 11 plus 3. Yes. 11 plus 3 is 14. So dimension is 14 by 11 feet. Okay. That's the answer. Okay. This is an application problem. It involves solving quadratic equations. Okay. All right. Okay. We have 1 minute, and how about let's briefly talk about this one. Okay. Because yeah, today we're supposed to start 1.6. I don't want to go like too okay. So this is some idea of this problem. So we have an L-shaped sidewalk. It's located from the athletic center to the library on a college campus. Athletic center, library. The length of one sidewalk from the L is twice as long as the other. So this is twice as long as the other. So you set it up as then the shortcuts. Okay, the sidewalk here is 32. Well, then you see this is a right angle triangle, right? And then right angle triangles, we have the Pythagorean theorem. So x squared plus 2x squared is hypotenuse, 32 squared. And x squared, 2x squared is 4, because 2 squared is 4. And then 32 squared. You combine the 1 and 4, you get 5x squared. And then, so x squared is 32 over 5. You see, this is a complete square. We can take square root on both sides. You get plus or minus square root of 32 squared over 5. Good. That's why we don't want to calculate what's 32 squared, because square and square root cancel anyway. So we get 32 over square root of 5. So that is the x. And then we want to find how many feet does a person save by walking on a diagonal sidewalk. So that's why the difference is, if we are walking here, the distance is x plus 2x, which is 3x. If we walk here, that's 32. That's why the difference you save by walking this path is 3x minus 32. Therefore, 3 times this number minus 32 equals 10.9 feet. You save 10.9 feet. So this problem is harder. It's not only asking you the x, but asking you how much you save. Okay. Yes. Have a nice weekend. So review your notes and do your homework. If you have questions, let me know. Bye.